This is GATE 2017 question number 50, which states that a person weighs WP at Earth's North Pole and WE at the equator. Treating the Earth as a perfect sphere of radius 6,400 kilometers, the value of 100 times WP minus WE by WP is what? It has to be taken that G is equal to 10 meter per second square, and up to 2 decimal places we have to give the answer. So let's see what the situation is. So the situation looks like this, that this is the Earth which is rotating with angular velocity omega, and this is the kind of a situation which is happening. So I will draw it here again. So suppose this is this curvature which we are talking about, and this is suppose that the axis of omega. So it is, Earth is rotating like this. So what is happening is that this is your equatorial radius RE, or the radius of the Earth RE. This is also the radius of the Earth from the center. Suppose this is the center. This is also the radius of the Earth RE. Let the latitude angle be phi. So if I draw this is also perpendicular. Then if this is phi, this is also phi, because these are two parallel lines. It's a kind of a transversal. So now suppose we have a mass over here of m. Then since it is in the rotating frame of motion, there will be a outward directing centrifugal force of magnitude mr omega square. So I have written it as r omega square as the centrifugal acceleration. So I have defined here r omega square is the centrifugal acceleration outward radially. Fine, this is radially outward on this mass. So this will be the centrifugal force, or this r omega square is the centrifugal acceleration. Now we know that if mass m is on the surface of the Earth, it will get a center directing gravitational acceleration g. So the g is in this direction towards the center of the Earth. This is the direction of the g. Right? Now, based on these two, that is on this mass, there are two forces which are acting. One is the gravitational force towards the center of the Earth, and another is the centrifugal force outward, radially outward from this particular direction. Its resultant becomes some g dash, the resultant acceleration due to gravity, or you can say that it is mg dash, or let me not write here the m. So this will be the r omega square, and this is g dash and g. G dash is the resultant vector, and as you can see that this r which is written here, this will change as we go from equator to the poles. This is the equator region. This is equator. This is also equator, and this is the pole. Okay. So this is equator, this is poles, and you can see this r which is drawn here, this will change as you go from equator towards the pole. At the equator it is the radius of the Earth, and at the poles it is absolutely 0. So r is 0 at the poles, and r is equal to the radius of the Earth at the equator. This is, we can see clearly. Fine. So RE is the radius of the Earth, and r, which is this one, this is r, is nothing but, if this is your RE, because if this is RE, then this is also your RE. So this RE cos phi is nothing but r. So this is fine. And if you put phi is equal to 0, which represents the equator, so this equator is nothing but phi is equal to 0, you can see that cos 0 is 1, so r is equal to RE. If phi is 90 degree, which is at poles, phi is 90 degree at poles, you can see that cos 90 is 0, so r will be 0. That is what we can clearly see. So r omega square is the centrifugal acceleration, which I have already told. G is the acceleration due to gravity on this mass acting towards the center of the Earth. It always acts towards the center of the Earth. Now the resultant acceleration is dependent on the latitude angle phi. Now we need to find out what is this resultant acceleration. Now according to the law of parallelogram of vector addition, we know that any resultant r of these two vectors a and b, if angle between them is theta, we can write the magnitude of r square is equal to magnitude of a square plus magnitude of b square plus 2 into magnitude of a magnitude of b cos theta, the angle between them. If we apply in our case where the vectors are r omega square accelerations. This is your g acting towards the center of the earth, and the resultant is g dash. And what is the angle between them? So the angle between them is that if this is phi and this is a complete line, so this line will subtend 180 degree. Therefore, if this is phi, this should be 180 minus phi. This should be 180 minus phi. The angle between g and r omega square is nothing but 180 minus phi. Fine. So I have taken here the force now, this mass into this g dash whole square, because g dash is only the acceleration. So I can always multiply the mass on both the sides. Ultimately it will cancel out. We can start with this also. So g dash square will be equal to g square plus r square omega to the power 4, because r omega square whole square becomes this. Why I have put minus here? Because cos 180 minus phi is nothing but minus cos phi. This is the thing, because it is in the second quadrant, and in the second quadrant cos is negative. Fine. So it will be minus cos phi. So this is what I have written. G is there already, and r omega square. Simple. This is just only this particular thing which I have written here. Now this term, if you look, r square omega to the power 4, the angular acceleration of Earth is about 7.29 into 10 to the power minus 5 radians per second. Now if it is 4 times, if it is made, is omega to the power 4, that should tend to 0. It's very small, 10 to the power minus 20 of the order. So it is very, very small. So this we can neglect. This can be neglected. Therefore, what I left behind is that g dash now is the square root of, because it was g dash square, so g dash is the square root of g square minus 2r omega square g cos phi. Now this omega square, this r omega square, or let us do one thing. I take this g common. So this becomes 1 minus 2r omega square by g cos phi to the power half. This can be done easily. Now r omega square is much less than g. Why? Because omega square is of the order of 10 to the power minus 10 and g is of the order of 10. So it's smaller. So what we can do is that we can binomially expand it, and we will neglect the higher order terms. Only one term we will keep, 1 or 2 terms. So g dash, it's just like this, 1 minus 2r omega square by g cos phi to the power half can be now written as g 1 minus this half is multiplied here. So 2 by 2 cancels out. So r omega square by g cos phi. This is the binomial expansion. Therefore g dash becomes, now I multiply this g minus r omega square cos phi. So this is the final expression. Now weight we can always find, because if the acceleration due to gravity is written like this, now weight is nothing but mass multiplied this, because weight is nothing but a kind of a force, and force is mass times acceleration. So I just multiply mass. So weight becomes force or weight. So weight becomes now, due to the resultant forces of centrifugal and the acceleration due to gravity, now the actual weight becomes mg dash, which is equal to mg minus mr omega square cos phi. Simple, multiply by m. Now what happens at poles? Phi is 90 degree. WP becomes mg minus mr omega square into cos phi, which is 90. So cos phi is 90 here, or cos, just a minute, cos, let me write cos 90, which is nothing but 0. Therefore this term is not there, only mg left. So WP is mg. At poles, WP, the weight that will be felt, is mg. But at equator, phi is equal to 0 degree, WE, this is the notation, is mg minus mr omega square into cos 0. Cos 0 is 1. Therefore mr omega square. But what happens to the r at equator at 0? We have seen at 0 degree at equator, r is nothing but re. You can go directly from the visualization, or from this particular formula also. If you put 0 degree, r becomes re. So r will be equal to re, the radius of the earth. Okay. Therefore WP minus WE, from this we can write WP minus WE is mre omega square, as r is nothing but re at equator. Fine. Therefore WP minus WE by WP is mre omega square by mg. This is what I am doing because of the question asks to find this particular term. So cancels out, we get re omega square by g, and ultimately you have to calculate into 100 to have it in percentage. So it becomes RE omega square by G into 100. And RE is, so let me calculate here, RE is about 6,400 kilometers given in the question. So we can write it as 6400 into 10 cube meters. Okay. The second thing is omega square. As I have told that the omega value is 7.29 into 10 to the power minus 5 radians per second whole square. So it's radian square per second square. This is the thing. And G is asked to take 10 meter per second square. So if you put this value in this expression, you will get the answer about 0.34. Okay. So if I come to the question again, so the value of 100 times WP minus WE by WP up to 2 decimal places is nothing but 0.34. And this is the answer. Thank you.